Okay, mathematical induction, this time proof of geometry results, which is a lot harder than normal one, and just like the other ones that we've done, so you need to watch more than once to get through this. Okay, just first question. There's only one question anyway. Let's read it. I want you to read it carefully. So we're basically looking for a formula that's going to give us the maximum number of a slice of pizza. So that's the table values that we have to use to find the formula. Okay, so I'm just done it like this. Okay, so that's the S1 value, that's S2, S3. Okay, now you need to see some patterns here, guys. So when I look at this, it's gone up by 2, that's gone up by 3. Okay, so it's gone up by 2, 3, maybe next one's plus 4. So it's not really constant, isn't it? It doesn't go up by 2 or go up by 3 all along. It actually changes. And then it go up by 1. Okay, finally. So if next one is 4, from 3 to 4 it's go up by 1. So it becomes constant. So you're actually looking for a pattern that it's going to get up by constantly. Okay, so first, it's not linear. The equation is not linear because it's going up by 1. If it's a linear, it's gone up by just constantly same number, wouldn't it? So it's not linear, it's quadratic. Okay, so that's the next up. Now, if it was going a little bit one more steps, then it'll be cubic. I just want to show you that. And SN. Now I'm going to change it to some other pattern here. So from here to here, what's that? Plus 2, plus 4, plus 7, right? And then from here to here, plus 2, here to here, plus 3. Okay, now from here to here, plus 1, and then the next one will be plus 1. So there's a regular, the constant happening here. So guys, if this here was a constant, it's linear, but it's not. Okay, so it's not linear, and this is not quadratic. Now it's constant, so it's a cubic. So therefore here, not linear, but quadratic, isn't it? Okay, so I can see the pattern. So when you see it's going to be going up by constantly, that's the actual equation you're going to stop. Okay, so not linear, not quadratic, then it's cubic. If it's not linear, but next one's okay, it's quadratic. So our formula will be quadratic formula. So it'll be A. So I'm going to stick with that. And I'm going to use these to find my ABC. So here we go. When S1, which is 2, when n is 1, so A plus B plus C. Okay? When it's S2 is 4, 4A plus 2B plus C. 1, 2. S3 is 7, 9A plus 3B plus C. Now, you've got 3 equations and 3 unknown. We can solve this. Okay? So what I'm going to show you is I've already done this in my book. So I'm going to show you this, what I've done. So I've done all that. So quickly have a look. And finally, I got Sn equals n squared plus n plus 2 all over 2 as my formula. Okay. Now another thing interesting here, because we have to use this a little bit later on. Now S1 was 2, S2 was 4, S3 was 7. Now if you look at the pattern of that, S2, the second term, is S1 plus 2, isn't it? Because S1 was 2 plus 2 is 4. S3 is the previous term plus 3. So it's like the term 2, 2. So I can make a pattern out of this. Just remember that because we're going to use that. Okay. So I know now what I have to prove is, I'm going to just use this one. So first we got Sn equals n squared plus, what was the formula? I forgot. Sn plus n plus 2 all over 2. Okay, so that's what I have to do. Okay, so we need to prove that. Step 1. So what is it? Prove true for n equals 1. So P1 equals the left hand side. I've got Sn, which is S1. What was S1 from the table? Was 2, wasn't it? Yep. And the right hand side, if I put 1 there, that's 4 over 2, 2. So left hand side equals right hand side. Therefore, P1 is true. Okay. Step 2. Assume true for n equals k. So sk equals k squared plus k plus 2 all over 2. Step 3. Prove true for n equals k plus 1. Okay, so I'm going to do sk plus 1. So if I sort of expand this one, right, I'll go k squared plus 2k plus 1 plus k plus 1 plus 2 all over 2, 3k plus 4. So if I can get that, that'll be all good. Okay, so I'm going to go left hand side. Now I need to separate this. Now do you remember, I told you to remember this. So I'm going to write this here. From the table, S1 was 2, S2 was 4, S3 was 7, right? And how can we find a pattern here? S2 is like S1 plus 2, yeah? S3 is what? S2 plus 3. So that's the same, yeah? So I can say Sn is Sn minus 1, the previous one, plus n. Okay? So I'm going to use that here. So I'm going to go, that means, what's the previous from k plus 1? It's k. Okay? And then the actual thing, like that. So that's what I've got. And then what I have to do is, what's sk from the second one? I'm going to replace that. So that's a k squared plus k plus 2 plus k plus 1. Now, I'm going to solve this. So it'll be 2k plus k plus 2 plus 2k plus 1 times by 2. So I'm going to have, so I'm going to go make it everything 2k squared plus k plus 2 plus 2k plus 2 plus 3k plus 4 over 2, which is exactly the same as what we got here. Same. So I can say the left hand side equals right hand side, and therefore pk plus 1 is true. but P1 is also true. And then step 4, we can say Pn is true by mathematical induction. Okay, that was a fair bit of it. Okay, so make sure you watch this video a few times and try to understand that. Okay, well done.